Hello. Today we're going to continue our conversation about the brain, but we're going to focus on the brainstem today. So here is a view of the front of the brain. All of this wrinkly stuff is the cerebral hemispheres. That little bit of brown that you can see right in there is the cerebellum, and this part is the brainstem. So focusing on this today. We can't see the diencephalon right now because it's like buried inside all of that stuff. And now I'm flipping it upside down because it's just easier for me to hold. I'm taking off the cerebellum. A little bit of the cerebral hemispheres just fell off on its own. There's the rest. So these are all the cerebral hemispheres. We're putting that away. And now we are left with this. That's the insula. So that is a little bit of the cerebrum still, but the rest of this is the brainstem. This represents major artery going to the brain. I'm going to go ahead and take that out as well. And just say this is a large gland sticking out. That must be the pituitary gland. And then over here, a little smaller guy, that number 25, that is the pineal gland. So the pituitary gland and the pineal gland, that's all of the diencephalon that we can see right now. If we open it up, then we'll be able to see the rest of the diencephalon in here. But this is our focus of today, which is the brainstem. So yesterday, or the other day, I was talking about how like you can't pick a most important part of the brain, but if you're going to pick a brain, like the hypothalamus is pretty important. Today, I would like to change my story, and I would like to say that if you're going to pick one most important part of the brain, it probably has to be the brainstem, because the brainstem is in control of all of the like automatic responses that have to happen to keep us alive. Like literally like making our heart beat, making our lungs inflate, all of those things. Like unfortunately, if someone damages their brainstem, they will most likely be considered brain dead, and that would be like in sort of a coma without having any sort of brain activity to recover from. So the brainstem is really where it's at. Oh, and notice that the midbrain is connected to the diencephalon up here, and then the bottom part, the medulla oblongata, that would be continuous with the spinal cord. So like you can't even tell like the difference. It's just like medulla oblongata, then spinal cord. Let's start with the most superior structure of the brainstem, which is the midbrain. And oh yeah, by the way, on this image, everything that's in green is the brainstem, and you might notice there's like a little blue channel flowing through it. That's an aqueduct, and it's carrying cerebral spinal fluid. So we can also see that goes down into the spinal cord, and then all the ventricles, those hollow chambers in the brain, are going to be filled with cerebral spinal fluid as well. But this structure right here is the midbrain. It's in charge of several reflexes. Like it has a visual reflex center that basically coordinates our eye and our head movement, but this would be like involuntary eye and head movement because it's in the brainstem. So it's kind of like if I'm like looking over there, my head like automatically turns so I can see it, or if I see something zoom by, like it automatically go this way. Like my eye and my head have to kind of work together to be able to see everything. The midbrain is doing that. Also brings information from the ears to the auditory center inside of the brain, and it controls some of our like startle reflexes. Like I'm really jumpy. If I hear a loud noise, look like and like jump like that. That is my midbrain kind of like overreacting. And I guess I'm trying to see if there's a good spot of it I can show you on the model. I'll just put my hands. The stuff that I'm covering up is the medulla oblongata and the pons. So everything like above it right there, that is the midbrain on our model. Pons is the center spot. So I'm going to do the opposite. That thing in the middle is the pons. And pons means bridge. I don't know why. Hopefully one of you can tell me that. But pons means bridge. And it sort of functions as a bridge between like the whole upper nervous system and the spinal cord. That might make sense to you because you could imagine how like a signal would be sent up the spinal cord, and then the pons is going to send it like to the thalamus or to another spot. And then the pons is also a really important bridge between the cerebellum, which is this structure right here, and the frontal lobe of the cerebral hemispheres. If you remember, the frontal lobe controls lots of voluntary movement. And the cerebellum, we haven't talked about this yet, but it controls like our balance and our coordination. So the cerebellum and the frontal lobe have to be constantly communicating to be able to produce like coordinated movements. And the pons is right there in between them, basically having those conversations. And then finally, the most inferior brain structure is going to be the medulla oblongata. And again, it's going to interface directly with the spinal cord. This is known as the autonomic reflex center of the body. So this is basically anything involuntary that has to happen to keep us alive is being controlled by the medulla oblongata. It controls, there's a cardiovascular center that's going to control our heart rate, like how fast our heart is going to beat. And it also can like dilate our blood vessels, make our blood vessels bigger to be able to control our blood pressure. There's a respiratory center that can control like how deep or how fast we're breathing. And also just like all the other centers that have reflexes that keep us alive, like vomiting, sneezing, coughing, hiccuping, anything like that that happens to kind of get something out of your body, the medulla oblongata is doing that. Also, you might remember that we talked about how the pituitary gland over here, part of the hypothalamus, doesn't have the blood-brain barrier. Part of the medulla oblongata is also missing the blood-brain barrier for the same reason. It needs to have direct access to the blood and be able to sense it and see what's going on inside of it. Here is that same picture, but kind of from a different view where we've taken the cerebral hemispheres away. So if you want to pause the video and try to identify everything. And hopefully you came up with this. So we can see the thalamus and the pineal gland from this view, and then everything in green is the brainstem. The top is the midbrain, the middle part is the pons, the communicator. That's why there's these thick nerve tracts around it. And then the bottom is the medulla oblongata, and you can see where the beige turns into green. It's meeting the spinal cord. There's all of these yellow nerves that are coming off of it. Those are cranial nerves. So anything that comes off of the spinal cord is either like a cranial nerve or a spinal nerve. There we go. So if it's coming off of the brainstem, it's innervating the brain, cranial nerve. If it comes off the rest of the body, it's innervating the rest of the body, and it's a spinal nerve. All right, let me know what questions you have.